Hey, Joel.
Hey, how you doing, Jessica, this afternoon?
I'm doing great. How are you doing?
I'm doing really, really well. Thank you for asking. And I appreciate you giving me the opportunity to talk a little bit about some installation concerns and installation overview with our new coil platform.
Yeah, let's get started. We've had a lot of requests about the brand new XAF and XAU coil, and everybody wants to hear from the tech guy himself.
Okay, well, no problem, but glad to do it. Well, as you can see on the front of my PowerPoint slide there, we've got two basic configurations for just a loose coil. You'll have a cased coil on one side and then an uncased coil. But in addition, this new coil platform is going to be migrating over into the air handler as well, as far as the configuration of the A coil and stuff like that in our air handler platform as well. So let's go ahead and get started. Welcome to the coil product overview today. Some key subjects we will be talking about will be as follows. We're going to talk about evaporator coil configuration for both a piston and a TXV, and some installation considerations. In addition, we're going to go ahead and talk about some of the features of the new coil platform that I think everyone's going to really enjoy. And so in this portion of the program, we will be discussing the evaporator coil configuration. I'm going to ask that you kind of follow along and just ask some good questions as we go along, Jessica. I know you always like to, but please don't be shy. Ask those good questions. We're going to talk about installing a piston and a Schrader valve core for fixed orifice operation. In addition, we're going to talk about installing a TXV for expansion valve operation. And please remember, all of the things that we're going to be talking about, it doesn't matter if it's a coil or an air handler or a loose coil, the principles are going to be exactly the same, as far as putting the TXV in or putting in the piston. So the principles will be identical. It's just a matter of, where the coil is actually going to be physically located on the indoor product. So as we kind of take a look at our coil platform here, you can see that for one thing, you can see it's an A coil. We've gone back to an A coil. We'll talk a little bit more about that later. But a big thing we always want to remember that the piston or the orifice or the TXV is going to go right onto that distributor body that actually bolts on. It's a threaded device, and so it's easy to just bolt on without any kind of problem at all. If we do have a piston, one of the things we always like to remind everybody, and you'll hear me say this a couple times, you're going to get a Schrader core, or you're going to need to put a Schrader core in for a piston system. And if you do put that Schrader core in for the piston system, you of course won't have an external equalizer line. Or if you do have an expansion valve, the external equalizer line will actually bolt on or on that flare fitting right there, because it's just a simple bolt-on device. So just remember, if you're going to use an expansion valve, the expansion valve bolts on, and the external equalizer line is just a screw-on flare type fitting as well.
Quick question, Joel.
Sure.
Word on the street is that the new units will not be using a piston. So why are we talking about a piston with this coil?
That's a really, really good question. The reason I went ahead and included that, Jessica, is because these are compatible with older equipment. And so as you know, on our current TC3 product, our straight cooling 13 SEER product, which we can still sell up north, it actually comes with a piston. And so it's rated with a piston. It's the only product in our inventory that's rated with a piston anymore. But because this coil is going to be backward compatible to older equipment, that's why we're talking about it. Good question.
So we can use this coil with, the new product that we're launching, as well as the equipment that we already have in the field.
That is correct. Good question.
Awesome. Thank you, Joel.
Yep. One of the neat things too about the new coil platform is it's designed to use only 2 expansion valves across the entire tonnage line. To me, that's remarkable. And so if you want to get specific on that, the TXV model numbers are going to be that S11 TVM. It's a BA1 and a BC1 across all those tonnages. I went ahead and included that just so everybody can kind of make a quick note. You might want to write that down. The BA1 will be for 1.5 to 2.5 ton products, and the BC1 will be for 3 and 4 ton products. And remember, team, you always are going to size that expansion valve on your coil based on the tonnage of the outdoor unit.
Joel, that is huge, because we used to have like 5 or 6 TXVs before?
Yes, and that's an excellent comment. So if you take a look at the outdoor product, there's going to be what we call a tabular data sheet. That tabular data sheet, and you're right. I mean, there was a half a dozen expansion valve combinations, and then really when you start looking at heat pump application, straight cooling application, sometimes on older product, we actually had a variant on that as well. So to be able to go on, to be able to have just two expansion valves for both straight cooling and heat pump on this new coil platform, it really is remarkable. I think it's going to be a real game changer out in the field, and especially, for our customers, our wind supply locations now, instead of having all these different SKUs, they're going to just have two expansion valves for the new coils. So I think that's pretty neat.
That's awesome. So one expansion valve for 1.5 to 2.5, and then one expansion valve for 3 to 5 ton. That's it. That's all they need to know.
That is correct.
Awesome.
Absolutely. So as we take a look at this again, I just want to remind everyone it's very, very important. Do not forget to install the Schrader core if a piston or an orifice is going to be used. Because remember, team, there's going to be pressure on this thing, especially in the heating mode of operation. If you go into the heat pump mode of operation, there's going to be high side pressure on there. So that little plastic cap is not designed to hold high side pressure on a heat pump in the heating mode of operation. So please, if you're going to use a piston, or if your system is rated with a piston, make sure it's absolutely important that you install that Schrader core if a piston or an orifice is going to be used. And if a TXV is used, do not, let me say it one more time, if a TXV is used, do not install that Schrader core. Instead, you're going to just bolt on that flare fitting for the external equalizer line for that expansion valve. Okay, let's take a little closer look at that new distributor. This new distributor body design, it actually improves liquid refrigerant distribution for better flow and capacity. And if you take a look at it, it actually looks a little bit different than our previous coil model distributor body. But as you take a look, if you look at it, it's still a bolt-on design, easy to hook up, easy to change if you have to change an expansion valve or a piston. But that bolt-on design has been just a real winner as far as our coil platform is concerned. One of the questions I get sometimes, though, hey, Joel, those little distributor tubes that are coming off that distributor body, can I still move that distributor body around up and down and side to side? And the answer is absolutely. You don't have to worry about kinking those small lines. They're very, very sturdy. They're very rigid, those small lines coming off the distributor body. So don't be afraid to move it around if you need to hook up your liquid line adapter. And by all means, just make sure they don't rub or they don't touch each other. Once you've moved it where you need it to go and so on, make sure you separate those lines so that they do not touch each other or you have a rub issue. Okay. Let's look at some of the features of this new coil platform. I'm pretty excited about this new A coil again. Let's talk a little bit about it. Well, it's a max alloy coil, and that max alloy coil provides superior corrosion protection and it's great heat transfer. As a matter of fact, it's an all aluminum coil. In addition, with enhanced fin design and materials, we're able to go back to a industry preferred A coil configuration. And A coil configuration is actually, it is preferred in the industry, but there's some good reasons to have an A coil as well. One of them is you have better airflow, and in addition, you have less potential for water blow off, especially in a horizontal application, which we'll talk about in a little bit. So as you take a look at this A coil, we've gone back to an A coil, and because we were able to manufacture and do some different things to enhance the fin design for better heat distribution, we're actually able to go back to that A coil again, which is actually an industry preferred configuration. In addition, we've got aluminum. I mentioned it before, but let's dig in a little bit more. I mentioned we have aluminum on aluminum components. So in other words, we have aluminum fins on aluminum tubing and aluminum end plates as well. So this totally eliminates any bimetal corrosion that you would get, for instance, like with a steel end plate and a copper tube and then aluminum fin. There you've got three metals that are interacting with each other with bimetal corrosion. So with an aluminum coil and aluminum fins and aluminum end plate, aluminum on aluminum on aluminum, so to speak, you eliminate that bimetal corrosion potential with the new coil platform.
Is that consistent for the uncased, the cased, and the new horizontal? Is everything aluminum now?
It is. It's going to be all aluminum. So you're going to have again, I like to talk about that. It's aluminum touching aluminum. So basically, anywhere condensate, water, or anything like that is going to run on that coil, aluminum touches aluminum, and so it just really enhances corrosion protection.
Got it.
In addition, our thermoset drain pan, it greatly improves condensate removal the way it's designed for increased indoor air quality, and it will never rust or corrode. Now, you'd think, why in the world would indoor air quality have anything to do with condensate removal? Because, well, remember something. Remember, team, what happens is if you can't get rid of that water, bacteria and mold and all that can grow down inside that water sitting in the pan. So we want to get that water off the coil. We want to get it drained down the drain and get it out of that drain pan. So that thermoset drain pan, it greatly improves that condensate removal. And again, it'll never rust or corrode. And so it's good, high quality material. In addition, on the coil itself, the new coil design has less potential for water blow off, especially with the new dedicated horizontal coil. And I want to stress that one more time, that the fact that you've got a dedicated upflow and a dedicated horizontal coil now, we can actually enhance the not only condensate removal, but also we can greatly reduce water blow off potential with that horizontal coil because of our new design. In addition, one drain pan instead of two, as found on multi-position coils, is going to improve airflow and efficiency. This is huge. I mean, if you have a multi-position coil, the fact about it is you're going to be stuck with two drain pans. But the fact that we have now a horizontal, dedicated horizontal and dedicated upflow, we get away from that second drain pan, and it improves airflow and efficiency.
So we're no longer going to be having the CM or the multi-position coil moving forward.
That is correct. Moving forward, we won't have the CM multi-position coil. But the truth is, I kind of like that because as I mentioned, with a dedicated horizontal and dedicated upflow coil, you can now choose what you need for upflow or downflow or horizontal. But you also get rid of that second drain pan, which was redundant. And if you think about it, on an upflow or downflow application, that second drain pan on that multi-position coil is just hanging there in the breeze, so to speak, and it actually disrupted airflow, and it actually reduced efficiency to some degree. And so I like dedicated coils, I always have, and I've always liked the A coil configuration, from an airflow and from an efficiency standpoint. Good.
Got it.
Okay. And all of our coils, we've had this for some time actually, but all of our coils are 100% leak tested with helium to ensure excellent reliability. Now, one of the things I like to talk about this real quick, if you remember back in high school chemistry on the periodic table, hydrogen was on one corner at the top of the chart and helium was on the other corner at the top of the chart. Well, helium is the second smallest molecule on the periodic table. So we use this little tiny molecule to leak test with. It's an inert gas, so it's very, very safe to leak test with it. But you use this little tiny molecule to leak test with, so it just really improves our leak testing capability on the coils. And the fact that the coils are 100% leak tested with helium, it just gives us a really high quality product that we know is going to be fine once it gets out in the field.
So this coil is going to go through the same testing through the mass spectrometer, similar to what the CF and the CM when we launched those products.
Absolutely. So that same coil testing procedure costs a little bit more money to have helium on hand to do all that, but it's definitely worth it to just give our customers a good, reliable product that's going to be very corrosion resistant and all the other things I just talked about. So with that, Jessica, let's open up the floor if you've got any further questions and stuff. And thanks everybody for their attendance on this program.
Joel, I have a question. We've had requests from contractors when they're hooking up the TXV or they're trying to get access to the lines. Why do we have a swedged cap? Why don't we use a plastic cap that's similar to a lot of our competitors? Why are we using why do we do what we do, and have there been talks of changing that?
That's a good question. And, I'm going to kind of fall back on some of my history with other manufacturers. And I won't mention any names, but some manufacturers, they have a plastic cap, and other manufacturers, they'll have like a rubber plug they put in there. And the truth about it is all of those things have a potential to possibly leak during shipping. And so the absolutely most reliable method of pressurizing that coil and keeping pressure in that coil, because remember, if there's positive pressure in that coil, if anything happens, it'll leak out instead of sucking stuff in. So it keeps moisture out. I mean, I like a brazed cap because you have that hard, solid brazed cap on there. And when we pressurize that coil, the chances of that coil leaking in the first place are going to be minimal. But secondly, I can't tell you the number of times, I've had warranty issues or had reports of warranty issues with other manufacturers because the plug came out, or the little plastic cap was cracked, and so the customer got this coil that had no pressure in it, and as a result, they thought they had a bad coil. Well, the truth about it is, a lot of those coils that got sent back for warranty, there was nothing wrong with them. All it was is it leaked out past that rubber plug or that little plastic cap, and so the most reliable method of shipping a coil is to pressurize that coil with a brazed cap on there, and then all the contractor does, he just cuts that off and swedges it, or you can put a coupling on there. But I've always been a big advocate, and I like the brazed cap. And oh yeah, it might take a couple more minutes to install it, but I like the reliability, and I also like the fact that I know that when I open that coil up, I've got pressure in that coil because it hasn't leaked past a plastic cap or a plug. And so that's why we do it, is to enhance reliability, but also to enhance confidence for the contractor. Because think about it, if you've got a plastic plug or if you've got a rubber plug, and that plug comes out and there's no pressure on that coil, he doesn't know if it's a bad coil or if it's that rubber plug that was bad. And so it's just a reliability and confidence thing in my mind. Good question.
That's probably something we're going to continue with moving forward, right?
Oh yeah, I certainly hope we do. Like I said, after been in the field a long time and seen what other manufacturers have gone through with warranty returns with a perfectly fine coil, I hope we stay with the brazed cap because I think it's just a better system. Good.
Awesome. Well, thank you so much, Joel. We're gonna make sure this is uploaded onto your famous YouTube channel. So everyone can watch this as often as if they need to, share it with their contractors. And any questions, reach out to you, right, Tech Guy?
That sounds real good, Jessica, and thank you for the opportunity to share some of this great coil story, this new coil story with you this afternoon. Thank you.
All right. Thank you very much, Joel.
Have a good day.
You too.